All right, welcome back. Okay, so next video, we're going to find the equations of the osculating circles for this ellipse, 16x squared plus 4y squared equals 64, at the points 2, comma 0 and 0, comma 4. Well, what's an osculating circle, you ask? I'm glad you asked. Osculating circle is a circle with the same curvature as the given curve at the given point. Okay, so let's go ahead and take a look at this specific case of what we're doing, because that's what we're doing, right? So, in this case, our 16x squared plus 4y squared equals 64. I'm going to divide everything by 64 just to, have it in the right form. So it's going to be x squared over 4 plus y squared over 16 equals 1. So that's our ellipse. It's going to look like so. Let me move it a little bit out of the way here, make it a little bigger. So our ellipse is going to look like, let's try it like this. Okay, not a great ellipse, but it'll do. And what we have is we're going to have some circle, maybe here, and another circle here. And sort of the idea is that if you want to know what's going on here, just right at this point or right at this point, you can kind of do everything that depends on curvature by comparing it with the circle. Okay? All right, so let's start. First, we're going to have to parameterize this curve. Okay. Parameterize the curve. That's a standard problem. We've been doing this for a while. So if you don't get it, then we need to talk. Okay. So our R of t, I'm going to do it just in the standard way, starting from here, going counterclockwise. Okay. So my x is going to be, what's that? 2 cosine t. And my y is going to be 4 sine of t. Let's just put a 0 on there. Okay. My r double, or my r prime of t, because here I'm going to find the curvature. Okay, so my r prime of t is going to be negative 2 sine of t, 4 cosine t, 0. My r double prime, that's going to be, excuse me, negative 2 cosine t, negative 4 sine of t, 0. And then let's take our curvature. Remember, our curvature is the magnitude of r prime cross r double prime divided by the magnitude of r prime cubed. Okay, so r prime cross r double prime is the determinant I, j, k, negative 2 sine of t, 4 cosine t, 0, negative 2 cosine t, negative 4 sine of t, 0. equals. So it's going to only have a k component, and it's going to be 8 sine squared minus 8 cosine, or plus 8 cosine squared. That's going to be 8. Okay, so we're going to have 8 divided by the magnitude of r prime cubed. I better remember to cube it because I did this problem already, didn't cube it, and now I'm doing it again. That's why you got to do things right the first time. Okay, so that's going to be what? 4 sine squared of t plus 16 cosine squared of t plus 0 to the 3/2. Okay, I'm going to write that as 8 over, now, I'm going to take 4 of these cosine squareds and put them with this sine squared to get 4 plus 12 cosine squared of t. Okay, so this is my curvature. Okay. Excuse me just a second. Okay, so we need to find the value of this curvature at this point and at this point. This point here, that's t equals 0, and this is t equals pi over 2, according to my parameterization, right? Okay, so we're going to do this at t equals 0, t equals pi over 2. So when t equals 0, what's this going to be? This is going to be 8. Cosine of 0 is, remember, 1. So it's going to be 8 over 16 to the 3/2. 16 to the 1/2 is 4. So 8 over 4 cubed. Eight over what? 64. 1/4. 1/8, sorry. Okay, 1/8, so that means it's going to be a radius of 8. Okay, so really what happened is that over here you actually get a bigger circle than your ellipse. Actually, it makes sense. I should have thought of that before when I was drawing the picture. Okay, so we need to find, let's draw a picture. We have a circle here. Touching it, it has a radius of 8. Radius of 8 on this side. So it's going to be centered over here. So it's going to be x minus, or x plus 6 squared plus y squared equals 8 squared. Okay, so that's the first one. Let me change the color on that. No, never mind. I'm not going to do it. Okay, let's go to the next page for the next one. So we're going to take a circle. Again, touching at 0, 4 with radius. Well, we haven't found it yet, but our curvature is going to be 8 over whatever this is. at t equals pi over 2. What's cosine of pi over 2? Cosine of pi over 2 is just 1, right? No, 0, sorry. Cosine pi over 2 is 0. Cosine pi over 2 is 0. Again, cosine pi over 2 is 0. Okay, so that's going to be 8 over 4 to the 3 halves. Okay, 1/2 of 4 is, I'm sorry, square root of 4 is 2. 2 cubed is 8. So our curvature is 1. So our radius is going to be 1 as well. Okay, 1 over 1 is 1. Okay, so that's going to be, think about it, 1, 2, 3, 4. You have a circle radius 1. So it's going to be x squared plus y minus 3 squared equals 1. Okay, so that's our other circle. Okay, all right, I'll see you all in the next video.